Okay. PM sensors measure the speed and position of rotating parts. That is true. The resistance of a PTC thermistor increases as the temperature it monitors decreases.
False.
What's PTC?
Positive thermal coefficient.
Positive temperature coefficient.
That would be my next guess.
Yeah, so as it gets hotter, it gets less resistance. That's why, or is it? Wait a minute. Think about it. It gets hotter, it gets more resistance if it's positive. If it's negative temperature coefficient, if it gets hotter, it gets less resistance, which is the opposite of what you'd expect. An analog signal continuously and smoothly changes in what?
What changes in?
Huh?
In?
That's false. We're just going to put false. There's nothing for it to be there.
Yeah. Well, what's an analog signal look like?
It's a waveform.
That's good. That's a good answer. Analog is versus digital. Is there a digital sensor? Is something you can show me in this room is digital?
Yes.
What? What about the light switch on the wall? You just turn it off and on. Yeah, it's digital. Off and on. Off or on. That's all. But what about the one?
Analog is the one that you use.
Or that you can turn the knob and the lights get brighter. See, all that kind of thing. All right. So basically, that's a goofily written question. It's kind of dumb. So that should have been true there. I don't know why. I don't know what happened to the last word. Automotive computers and control modules use analog signals converted from digital signals.
Isn't it the opposite?
Well, not really. They like to, how do you, oh, I'm see what you're saying. They got digital converted to analog. That's what you're talking about, yeah. Yeah. I was thinking the opposite of what you were saying, I guess. So number 4 is basically false. Digital, how do you convert an analog signal to a digital signal?
You use an analog to digital converter.
And how does that work?
If I remember correctly, it takes the waveform and it converts it into zeros and ones. That's why when you look at a digital waveform, it's what is it? Pits and or peaks and falls.
Okay, you're typing the algorithm, so how are you going to make it work? So you're tapping the algorithm, so how are you going to make it work?
0, 0, 1, 1.
It's not too hard to figure out. All you got to do is say, when I see a voltage that's above a certain voltage, I'm going to call that on. When I see it drop below anything above that voltage, I'm going to consider on. If I see it drop below that threshold, I'm going to call it off. See what I'm saying? That's not complicated, really, if you think about it. All you have to do when you're typing the algorithm is give it the threshold. Anything above this, you know. And if you've ever typed computer programs, and I have, you say, you know, if this is greater than, then do this. If this is less than, then do that. It's not complicated. Okay, I do this before Bobby goes to sleep.
Yes.
Okay, right here we've got. Let's see, the entire PCM must be replaced if a change in programming is needed and the PROM is not replaceable.
I don't think it needs to be replaced because you need to reprogram.
Well, it depends on the year model. On that 94 Lincoln, you cannot replace the PROM, so you'd have to put the whole PCM on it. On the truck that Quincy's folks brought up here, we had to replace the engine controller. You know, because you can't, now that you don't do that on a Ford, unless it's an 83 or older. You know, they had a, you know, thing right there. But anyway, if you can't swap the PROM, like on the PROM on my dad's 96 Chevrolet pickup truck that we had in here, you remember that?
Yeah.
We got a bunch of the engine controllers. You don't know if it's a V6 or a V8 from the number of it, but the PROM is what makes the difference, see? And we swapped PROMs until we found the one that made it run right. And it runs like a sewing machine right now. A shift solenoid can be tested with a DVOM or by air testing. Which way?
Oh, air testing.
Yeah. Well, yes, you can. How would you test it? If I put a shift solenoid in your hand, how would you test it by air testing it?
Pressurize.
I got 2 wires there. I'm going to hook one to power. I'm going to get rid of the other one where I can touch it to ground, and I'm going to blow through it. And whenever I touch it to ground, it should stop up. I've air tested it, but I can get my digital voltometer and I can test it too. Now let me tell you something about automatic transmissions. If you ever rebuild an automatic transmission, if you're going through the whole thing and you're at that stage where you're going to be rebuilding automatic transmissions, you're doing yourself a disservice if you don't go ahead and replace the electric solenoids while you're in there. Because that could cause you to have to pull it back out, particularly if the doggone thing's front wheel drive. Got me? So I mean, we've run into that. You try to get by as cheap as you can. If you don't replace those solenoids, you got to go back in there and replace them all the time. Vehicle sensors produce an output signal that can be either analog or digital.
True.
That's true. The ones that I like to talk about, if you look at wheel speed sensors on a lot of vehicles, they're actually analog and they create a waveform. But on the one that on that Dodge Caravan that Jimmy drives, that we inspect, the wheel speed sensors on that one have put out a digital signal. They're Hall effect sensors, and that digital signal is basically going from 7 to 14 milliamps up and down. It's a peculiar thing, but you can read it with one of these little yellow meters if you know what you're looking for. 2 wires going to it. One's hot, one's ground. You go into that hot wire, you turn that wheel, you'll see that voltage deflecting, and you'll know the sensor's actually reading. Those sensors die all the time, though. OBD, that was funny because when they first put those on the Jeeps, like the one that you guys put the motor in, I fixed one of those that had a bad wheel speed sensor on it. But they had just started using Hall effect wheel, and you cannot use a meter to measure the resistance of the wheel speed sensor. And so I changed it out, got it fixed, and the guy called me from Chrysler. And he says, I've got a warranty claim here where I see that you've replaced the wheel speed sensor to fix this, ABS light on this new Jeep. And I said, yeah, I did that. And he was real, sort of looking down his nose at me, you could tell through the phone, And he says, how did you determine the wheel speed sensor was bad? And I said, well, it didn't work, and I took one off of another new Jeep and put on there, and it worked. He says, oh. Well, he thought he had a gotcha moment. You know what I mean? Because he thought, you can't test that with a meter. And I was thinking, when he saw that I just did an ABA swap, well, you can't argue with that, because if it worked when I changed it out, ordered another one to put on the other Jeep. OBD1 technology can diagnose and detect only system failures and system degradation.
Sure, why not?
What do you think?
False.
Who likes that? That's false. Don't say. One of the buzzwords. What's the buzzword when you're doing a true/false question?
Only.
Only, always. You see that? That's a bad one. Serial data can be used when a no code condition occurs.
True.
Yes.
That is true, but what about this? What if something has shorted out my serial data line, or like on one of these Fords, if it shorts out the reference voltage line, it won't start and you've got no data.
No, you see, here's what you do with that. Push in a river.
Yeah. Well, no, basically what I had a police car that I couldn't push in the river that I was driving, and when I was turned, when I was in the I would get in a place, when you turn, it tries to stall. And so I was turned and it would try to stall. I straightened up and it come back. And I was in the parking lot down there at the mall, because I was still working at the Ford place, and I would turn and try to stall. I come back and come back up. I said, now this is interesting. And so I got down there and I had all of my stuff hooked up to it and then I noticed when I turned and it stalled, this time it wouldn't start. I said, oh crud. So here I am down here with a dead car in the mall. And so it wouldn't talk to the scan tool. Serial data was gone. So if the scan tool won't talk, you can have a snap-on scan tool that costs $9,000, and if your serial data is down, you may as well put that thing back in the box and do something else. Well, what happened was, and I'll tell you what happened, this is important, listen, some yo-yo that was to pull the gas tank off, put it back on. That sensor, that little pressure sensor in the gas tank that tells this for the evaporative system, you see on all these? Somebody had dragged that wire across a sharp bracket when they put the gas tank back in. And whoever worked on it at the police station, at the city shop, and when they plugged it in, it was the car would flex a little bit, and it kept on until it sawed through that wire harness. Reference voltage is going to that sensor, and when it shorts out, you've lost your everything that the computer doesn't know what to do. Now, not every vehicle does that. These Chevys, when you short reference voltage, as far as I've been able to tell, they don't do that, but on the Fords they do. But anyway. Make sure that if you only got serial data though, your scan tool is useless. Automotive transfer cases are either single speed or double speed. What do you think?
False.
What do you think, y'all? That's false. In a transfer case with electronic controls, the actual shifting is done with stepper or vacuum motors.
Yeah, I'd go for it.
That's true. Hard shifting or jumping out of gear can be caused by a bent shift linkage.
True. True.
Doggone sure can. My dad had a Volkswagen bug he drove that jumped out of gear, and he didn't have time to take it apart and fix it because he was so busy in his shop. And so he took a little piece of steel rod, cut the right length, and he fixed it where he could prop it against his dash and hold it in gear. So he didn't have to. That's what you do, My dad was a dynamite mechanic, one of those old bugs. He could just listen to one run and tell you what was wrong with it. And one day I was riding with him on his car, and it bucked and jumped and cut up a little bit. I said, "What was that, Daddy?" And he goes, "I don't know. It throws a fit like that every now and then." And it just surprised me that he didn't have a postulation as to what it was, because I was thinking he knows everything, you know. Okay, the first step in removing a transfer case is to drain the lubricant. No, that's false. The outside of a transfer case, you don't have to drain the lubricant in a transfer case if you don't want to, because it's typically you're not going to lose a lot of that. Just pull the transfer case off there. The outside of a transfer case should be cleaned before disassembly.
I agree.
That is true. That is the right way to do just about everything. When overhauling a transfer case, replace all bearings whether or not they show signs of wear.
True.
False.
What?
You don't replace the bearings when they're not worn out, please. That's unnecessary expense.
Bearings and everything.
When reassembling a transfer case, check critical clearances with a feeler gauge or a dial indicator.
True.
Does everybody know how to use a dial indicator in here?
Yes.
If you don't, you ought to. That's all I got to say. A stepper motor moves its output shaft in increments such as a quarter turn or a half a turn.
True.
How does it work? And that is actually false, by the way. It doesn't use, it barely moves it any at all. It's just a tiny little bit. Okay, so how would it work? You got a stepper motor? How are you going to use a stepper motor to do any good with it? I've got a screw, and I've got to hook to that armature, and as that thing turns, that screw, you know, it actually screws that thing out and screws it back in. That's how these idle air control motors work on GMs and Chryslers and stuff. On the Fords, it's slightly different. But anyway, it's basically going to do more than that. Those steps are more than a quarter of half a turn. They're going to be a lot finer than that. Driveline wrap-up or driveline wind-up is a term used to describe the proper load on the proper load on the drivetrain universal joints when the vehicle is on a slippery surface. That's kind of a crazy question. Using a lift kit to raise a vehicle changes the vehicle's center of gravity, but not its driveline angle.
False.
Everybody knows that, don't you? How many people have seen this one guy driving down Gulfway Drive in Port Arthur one time? He was going along here on his Camaro or whatever, and some yo-yo had jacked his four-wheel drive up too high or something, and the drive shaft came out from under that thing and just beat the crud out of his Camaro. It just banged the whole side of it all up, you know. I mean, it just came apart under there. And this is another thing. You know that little yoke that hooks to the rear end? That, you know, where your drive shaft and where your U-joint goes? We were in a '69 Plymouth one time, a bunch of high school boys, and we had gone out there and we caught a possum. What we did, we used to possum hunt, and we caught a possum, and we didn't have a bag to put it in. You only caught a possum, you take him back, you feed him with corn and stuff to get all that scavenger stuff cleaned out. And then at Thanksgiving, my bud's mom would fix a ham, a turkey, and a possum. You know, that's what they ate. But anyway, yeah, well, this is another century, man. Okay, so whatever happened, we lived in the country and all that, but whatever, and it was pretty good. It tastes like pork roast, but this is embarrassing, isn't it? One way or another. So we had that possum under the tire. We had that possum under the tire in the trunk, because we were going to put him in a sack when we could. Yeah, you're good to go. Yeah.
Where the key's at?
Yeah, your key is in the car and you're good to go.
Is it right out here?
It's parked out there.
And there's somebody else here for you.
Yeah, tell her I'll be out there in just about a minute or two, just real quick. Okay.
All right, possum under the tire.
So Danny is driving the car. He gets in the car, and we were just sitting there. You know, he wasn't driving crazy. He never did. You know, and he put it in gear. And when he did, for some reason, that yoke popped. It just snapped. I mean, I've never seen that before or since. But it popped in two, and the drive shaft was going under the car. It scared the daylights out of you. You know, we just knew that possum had come out from under that tire and was trying to get in the car with us. You know, but anyway, but what happened was his dad. He says, and the car wasn't all that old either. And his dad says, "I can't believe that you were out there spinning tires on a $3,600 car. You know, because that's how much it cost new, a '69 Plymouth." But anyway, that yoke had to be replaced. And I've never seen a yoke like that break before or since. And it just popped in two. And all he did was put it in drive. I mean, I was sitting in the back seat when he did it. And of course, the thing banging up under the car and everything scared the daylights out of me. I could just see that possum coming through the back seat. Of course, they're sort of docile. They'll walk along and hiss at you whenever. Yeah. Anyway, but anyway, viscous couplings are tested with a torque wrench, and that is true. It's not too hard to figure out.